Show. Brought to you by the Club of Amsterdam.
So my name is Maarten Stol. I work as a science advisor on the research team at BrainCreators. BrainCreators is an Amsterdam-based AI company. The reason that we're involved with AI is AI has known big leaps forward in the last few years. So we see that there is a place for a business like ours. A lot of our work involves machine learning. Originally just a part of AI, but now really the main actor on the field, on the stage of AI. So we have a team of AI engineers who work with neural network technology, and my own research department is tasked with keeping the company up to date with ongoing academic research in this field. So I can give you some examples of what we did in the past few years. One example is that we worked with a steel manufacturer in quality control. So this was involved camera images and camera data from steel sheet production. So the steel sheet is coming from the presses, and it can or cannot have certain defects. Then knowing the defects is important because you need to be able to trade on the global steel market with these products. So the steel is put into coils, and the coils are then put on the market. If you know about this particular state and quality of a coil, you can ask the price for it that it deserves. So that is an interesting part where quality control and trade comes together. There's also a practical side to it in that some of the defects in the production process also can be so severe that production needs to be stopped, or there needs to be some kind of intervention in the production process. So for that also live monitoring of the production process is important. For us, this is typically a computer vision project. So we work with labeled data to make an image classifier, object detection technology that looks at these type of camera images. Of course, computer vision and object detection is a recurring theme. So we see this in other businesses as well. Just recently, for something completely different, but also object detection, just recently we launched our brain matter platform, and together with a American company that works with fashion photography, we launched at the Oscars our product Fashion Brain, and that's all about detecting clothing and celebrities and luxury item in fashion photography. So from our side, this is very similar technology. Of course, on the outside, it's a completely different application. But this is just one example where you can see that modern day AI tooling has become powerful enough to apply across very different verticals. Yeah, well, there is an analogy, but I would say it is a very remote analogy. So when we say neural networks, so this neural technology is very loosely mimicking the way that human brain cells work. But the architectures that we build from these building stones is no longer human at all. Also, the learning process is not at all how we learn. You and I are very quick to learn with just a few examples. I can show you something that you've never seen before and just give you 3 examples. And when I show you number 4, you can say, yeah, that's the same class of object. Neural networks are not like this. They need typically in the order of hundreds or thousands or tens of thousands of images in order to finally get the point of how to classify these images. So no, there is a very remote analogy, but they don't learn like humans learn. Yeah, so we typically look for places where there is repetitive but expensive work. So typically, you know, the example of the steel sheet quality control, human experts were needed to do this kind of inspection of the product. And these would typically be knowledgeable human experts, and they're expensive. but they're doing a repetitive task. This is the kind of task that we hope to automate with AI. And in that sense, AI is not ready to step into every type of task. It's typically these types of tasks. And there's another thing, we can only apply this machine learning if the right labeled data is available. So that means that as your experts perform their task, we hope that they also gather data while they do it, so that we can learn from their examples, that the AI can learn from their examples. If this data gathering is not done in the right way, then we have an obstacle, and it's still hard to apply machine learning in a straightforward way. And I see the next topic is about, are employees more actors than spectators? Well, that depends really on what you mean with this. So I think the most important thing is, I already touched upon this in just my previous point, is that typically we are interested in gathering valuable data. So some business processes produce valuable data. I mean, when, let's say, a doctor or a radiologist is judging what he can see on a medical image, then this human judgment serves as very valuable metadata for this image. So this is an example of, as a human actor is doing his or her job, he's creating valuable metadata. And in this sense, a human is an essential actor in this process. We cannot do without him. On the other hand, maybe at some point you become partially a spectator, because, and that's maybe one of your next points also, is that it's not so much that we're trying to replace this type of human expert, but that we're trying to make the work more efficient and allow them to focus on sort of the outlier cases and the exceptional cases where the human attention is really needed, and the repetitive work for which the expertise is needed is taken away from the human expert. Yeah, well, I don't know. I think it's more a question of how long can you afford not to invest in this type of technology. So what I sometimes see, and I see this with customers, but also in society at large, is that we tend to think of innovation as something that is optional, right? We are so used to the status quo that we think that innovation is something that we can choose to do or not. Whereas in business, sometimes I see cases where I think, well, you're now doing something one way, but how long can you afford to keep this up? At some point, you're going to have to innovate and try to automate some of these tasks. So in that sense, it's not a matter of, can you go back? It's more a question of, can you afford not to go forward? Well, typically the sort of learning that we are now doing with neural networks, that there's two types of learning that we're doing. And one of them is really about learning to discriminate between different cases. So you are looking at images, or you're listening to sounds, or you're looking at sensor data, and you're learning to discriminate, let's say, between good and bad, or between cases A, B, and C. This is not necessarily how you and I learn. When you and I learn, we tend to learn sort of abstract processes and then apply these abstract thinking to specific cases that we are presented with. In that sense, machine learning today is much more limited than the learning that you and I do. Another issue is using contextual information. You and I are very capable of applying what we learn in one context to another context. This contextual flexibility is something that modern day neural networks do not yet have. Research is being done, but typically we would need to retrain a machine learning model for a different task all over again. So in that sense, a machine learning model can process much more data, but it is also much less flexible than a way a human learns. Well, I see it more as a support role, for now at least. Maybe in the future you can have this really self-sufficient type of application design. Right now, I think current day AI is more of an assistant. So maybe if you are looking for bugs in your software, or you are testing a GUI design or some general software architecture, it could be interesting to have AI related tooling to help you do this task. But again, it's either going to be based on data, so examples, and you're going to need a lot of examples, or you're going to have to look at a more classical AI approach where you do actual reasoning, where you look at the code, run the code, simulate it, and do sort of more intelligent testing with the code than software engineering has been doing until now. I don't yet see a completely self-sufficient AI that you can just push a button and it will design your next killer app. Yeah, so of course the future of the labor market is a very important issue, and I think AI is going to have an impact. I am a careful skeptic about the possibilities of AI, so I don't believe in mass unemployment in, let's say, the next couple of years. But I do think that jobs are going to change, and specifically I think manufacturing is going to be automated more, but I think we need to be careful not to confuse automation with what is sometimes called augmentation, and augmentation is about this support role again. So I think a lot of jobs are going to get AI support, and in that sense, the jobs are going to become more efficient and human expertise can be applied in a much more specific way. That's also why I think that augmentation is not necessarily a bad thing. A lot of our energy and efficiency right now is wasted, and we could use this in a much more efficient way. There's another issue with the future of the labor market, and that is, I think, so yes, some jobs are going to be automated away, but I think also a lot of new jobs are going to be created. And then maybe you can distinguish between, on the one hand, jobs that are being created, like a company like ours, sort of the technical engineers that are needed. I think this will be a relative minority compared to the rest of the labor market. But also I think as the economy and other companies become more efficient, it also means that they could possibly expand their business and simply by this expansion create more jobs. So there is, some people are of the opinion that simply by making processes more efficient and partly augmented or automated, we're also expanding. So the job market, the labor market is going to change. Whether there is going to be a netto effect of jobs disappearing, I don't believe so at the moment, but it's difficult to predict the future. Yes, I can. Specifically, our viewers in Europe, we need to be aware that the big progress in AI currently is being made in China and the United States. And that if Europe, or the country where I'm from, the Netherlands, but I think Europe at large, wants to be a significant player in this field, we need to be able to come up with fundamental strategy in terms of AI and machine learning. So some countries are actually, from the government initiative, are actually making money available for universities, for education, for projects, but I don't see this enough yet. And I think that we could possibly miss the boat on this if we don't invest enough time and effort in this in the coming, let's say 5 years. Right, so I think there are several levels at which this could happen. On the one, it could happen in terms of human experience with this technology. So also we as a consultancy company, knowledge transfer is an important part of our business. So we make our customers self-sufficient and be able to continue working on this technology on their own. So that's a transfer of human experience and human expertise. But it also is on the level of data. So data sharing could be a very interesting future, where one company has a data set to learn one thing, But if machine learning models become advanced enough to actually learn from each other, you could have something, in the field of machine learning, this is sometimes called transfer learning, where you train a model on one data set and then reuse parts of this model or parts of the ways that it processes data on another task. Now, right now, transfer learning is being done sort of in a piecemeal way. So these models don't actually actively talk to each other. But sometimes I fantasize about a future where also machine learning models are going to have their own type of internet. Just like when we got the first internet, our home computers and personal computers became connected and could actually start to share services. At some point, it's imaginable that machine learning models could also start to interact, share information, and in that sense, specialize in certain subtasks and share out this specialization. We're not there yet, but this is something that could happen in, say, the next 5 to 10 years, that it becomes quite easy to connect these models and also economize on this, right? Because if you captured certain tasks in your machine learning model and you own this model, maybe you could lease out the knowledge that is in this model, and in that sense, a whole new economy could start based on this type of transferring of learned knowledge. Well, I think the fear at this moment is mostly emotional. There are many things in the modern world to worry about, in the economy, in the climate, etc. And AI is one of them, but it is only just one of them. I think there's a lot of fear of the unknown, and also I think it is a fear that has to do with the issue of control. So whenever people feel that they are not in control of something, they produce this type of fear. And of course, it doesn't help that we have a whole generation of science fiction movies to actually promote this type of fear, right? It began with 2001: A Space Odyssey, and then 100 other movies use this type of theme, right? But I think AI in and of itself, it's not really justified to be that much afraid of it. I think we need to think very carefully how we want to shape the 21st century. AI is going to be an important part of that, but so is the energy problem, so is the waste problem, so is medical problems, financial problems, etc. And if you take all of these together, I think AI is a net producer of possibilities and potential to actually help solve these problems and not a threat. Oh, yes. Well, thank you, Felix, for having me. Thank you for the audience for your time. I hope you liked it. If you have any more questions or you're interested in what we do, look up braincreators.com or send me a line on LinkedIn or on email. Please do so. Thank you very much.